Hello everybody and welcome back. Today we'll talk about abstract classes and interfaces inshallah. Let's start by talking about abstract classes. Before talking about abstract classes, let's talk about abstract methods. Now, you can declare an object without defining it or initializing it. For example, person P. In this case, we are declaring P as a person, but we did not instantiate it or initialize it. Similarly, we could do that with methods. We could create the header of the method, as you can see here, public, and we add the abstract keyword voided row. So in this case, we are not adding the body of the method. We are just declaring the header of the method. This is called an abstract method. So an abstract method is a method header without its body. Now, what is an abstract class? Any class containing at least one abstract method is considered as an abstract class. What is the syntax of declaring an abstract class? It is as follows. We add the keyword abstract before the keyword class, then the class name. Now, don't forget that an abstract class is incomplete. It has some missing method bodies. So, according to that, we cannot instantiate any object from abstract class. After creating the abstract class, you can extend it. Now, if the subclass defines all the abstract methods of the superclass, in this case, you can create objects from this subclass. Now, note that you can create an abstract class without any abstract methods. This will prevent the instantiation from this class. Why to have an abstract classes? Suppose we want to create a class shape with subclasses oval, rectangle, triangle, and so on. However, we don't want to allow the creation of a shape, the general class. We only want to create the specific shape, for example, a new oval, a new rectangle, and so on. In this case, the good idea is to use an abstract class. Abstract classes are good for defining a general category for common characteristics between classes without defining the details. Now, why we did not solve the problem using inheritance? So, we create a class called shape. In it, we will not define the draw function because in this case, I don't want to draw the general shape. We want to draw the specific shapes, which is a star and crescent. So, we will create another class called star that extends shape, inherit from shape class. In this class, I will be creating the draw function. Then, third class that is crescent that will extend the shape class as well. Now, in the main, we will be creating an object of type shape and we will instantiate it to be a star. Then, we will call the draw function. This will occur a problem. We will have a compilation time error. Why? Because the draw function was not defined in the shape class, in the superclass. So it cannot be called. Here is the solution. We will create an abstract class called shape in which we will create abstract method called draw. This method will have no body. Now, we will create another two classes, star and crescent, which both will extend the shape class. In each of them, we will write the draw function accordingly. Now, in the main, we will create an object of type shape and we will instantiate it with star in this case. Now, we could call the draw function normally and this will never raise any error because the draw function was defined in the abstract class shape. Now let's move to another important concept in object-oriented programming, which is interfaces. What is an interface? An interface declares methods, but it does not provide bodies for them. A famous interface that is predefined in Java is the key listener. Now, all methods in interfaces, they are implicitly public and abstract. You cannot instantiate an interface just like what we have said in the abstract. However, in the interface, all the methods must be abstract. In the abstract class, don't forget we said that one method that is abstract is sufficient to make the class as abstract. However, in the interface, it's not enough. All the methods must be public and abstract. An interface, it may have data type in which they should be constants. For Java, we don't say constant, we use the keyword final. Designing interfaces. Most of the time, we will use existing Java interfaces. However, sometimes you want to design your own. In order to write your own interface, you need to follow the following syntax. We use the keyword public followed by interface, and then you put your class name or interface name. Then open brace your abstract methods. Then at the end, don't forget to close your brace. As we said previously, variables declared in an interface, they must be public, static, and final. Now they must be initialized at the time of declaration, otherwise your compiler will raise an error. You can see here an example of interface called printable, in which it has one variable which is integer min equals to 5, and it has one abstract method called print. Now, the compiler will automatically add public and abstract keywords before the interface method. Moreover, it will add public, static, and final keywords before the data variable. Implementing an interface. We extend classes, but we implement interfaces. Now, when you say a class implements an interface, now you are promising to define all the abstract methods that are defined in the interface. You can see in this example, we have class myListener that implements two interfaces. This is also an important information. A class can implement more than one interface. However, a class can extend only one class. You can see in this example, we are defining one interface called drawable, in which we have one abstract method called draw. Then we are creating two separate classes, rectangle and circle. Both of them will implement the interface drawable, and they will define the abstract method draw according to them. Then, in the test class, in the main, we will be creating an object of type drawable. We will instantiate it to a circle. Then, we will call the draw function. The output that will be outputted to the screen is drawing a circle, because the draw function that will be invoked in this case is the one that is implemented in the circle class. Okay, so why do we need interfaces? Without bothering about the implementation part, we can achieve the security of implementation. In other words, interfaces will be like contracts that all classes must respect. Now, another thing, we have studied before that in Java it does not allow multiple inheritance. However, in interfaces we allow multiple implementation. Last thing, Java interfaces they represent is a relationship that you have studied in UML. This graph summarizes what we have said in the previous slide. You can see in this table a simple comparison between interface and abstract classes. Let's start by comparing the fields. As we said, in interface we allow only constants. However, in abstract class, constants and data variable are allowed. Now regarding methods. Interface allow only abstract methods. All the methods shouldn't have body. However, in the abstract class, it allows both. Now let's move to comparing interfaces and classes. An interface can extend multiple interfaces. However, a class can inherit only from one class, as we studied before. An interface cannot extend a class, but a class can implement numerous interfaces. In an interface, you cannot instantiate variables or create objects. However, it's not the case in classes. We can create objects from any class. In interface, only one access specifier is allowed, which is public. In classes, as we studied before, we can use all access specifiers, private, protected, and public. Now you can see below the table a graph that will illustrate what we have said in the table. The first one, a class can extend only one class. However, a class can implement multiple interfaces. The last one is an interface can extend more than one interface. As we said before, implementation of interface is considered as contracts. So, any class that implements an interface, he must redefine all the abstract methods in the interface. He could as well implement other methods. Now let's take an example of multiple implementation in Java. In this case, we are creating two interfaces. The first one called printable and the second one is showable. Both of them has one abstract method which is called print. Now, we are creating a class called testinterface3 that will implement both of them. In this class, we are implementing one method which is print. Which print? Is it related to printable or showable? It does not matter. Both of them are abstract methods. They don't have body. In this case, in test interface 3, we are simply printing hello. So now in the main, let's create an object of type test interface 3 and let's call the function print. It will definitely print hello. No ambiguity in this case. Interface inheritance. In this example, we are creating an interface called printable, which has also abstract method called print. Then we are creating another interface called showable, but in this case, it inherits from printable interface. We said an interface can inherit from another interface or more than one interface. In this example, we are showing only one inheritance. Now, interface showable has another function abstract method called show. Now, we are creating a class called testinterface4 in which it will implement the interface showable. Since the interface showable has the function show plus print, because don't forget this is a subclass from the interface printable. Now test interface 4 will be implementing both function. Print, that it will print hello, show, it will print welcome. Now in the test class in the main we are creating an object of type test interface 4. Then we are using this object to call print function and show function. The output will be as follows. In any object-oriented programming language, an interface cannot be instantiated. Now in Java 8, there is a new thing, which is the default methods and the static methods. We will be explaining those in the next slides, inshallah. Now, let's define the problem. What will happen if I want to add a certain functionality to my interface? Given those information, this will be a problem because if I add an abstract method to my interface, this will break all the existing implementation of my interface. You remember what we said? The implementation class must implement all the abstract method of my interface, but this is a new functionality. Then I need to update all the implementation classes after adding this new abstract method. What is the solution in this case? It is default methods. A default method has the body. It has the full functionality. So we will add this to our interface. In this case, we have the functionality and we will save our previous implementation. We will keep them untouched. Let's see this example of a default method. Now we are creating an interface called A, in which it has one default method called foo. It will be printing a message. Now we are creating a class called class that will implement this interface. In this case, we are not adding anything to this class. In the main, we will be creating an object of type class, and then we will be calling the default function. It will be printing the message. Static methods in interface. Aside from being able to declare default methods, we could as well declare and define static methods in Java 8 and above versions. Since static methods, as we studied before, they don't belong to a particular object, they belong to the class. So in order to call any static method, we need to use the class name dot the static method name. In this example, we are defining an interface called myInterface, in which we are defining a default method called new method. It has its own body, as you can see here. We are defining as well a static method called another new method with its body. Then we are defining an abstract method called existing method, of course without body. This is an abstract method. Now let's create a class called example to implement myInterface. In this class, we will be definitely implementing one method, which is the only abstract method that I have in my interface, which is existing method. Then, in the main, we will be creating an object of type example. We will use this object to call the default method, which is a new method. Then, I will be calling the static method using the interface name, as we said. So, in this case, my interface dot another new method, which is the name of my static method. Finally, I will be calling the abstract method that was defined in the example. So I will use the object name dot existing method and I will give it the message. The output will be as follows. Now let's take one example of predefined interface in Java, which is comparable. Java comparable interface is used to order the objects of the user-defined class. You can sort the elements on the basis of one member only. For example, it may be name or age attribute or any other attribute you want. In this interface, there is only one abstract method, which is compare_to. This method can return three different values. A positive integer will be returned if the current object is greater than the specified one. Negative integer if the current object is less than the specified object. 0 if both objects are equal. Now we are creating a class student that implements comparable interface. In this class, we have three attributes: roll number, name, and age. We have the constructor, as you can see. We are implementing the abstract method compare_to. We are sorting the student according to age. Then we have the toString in order to print my student. Now you can see in the main, we are defining an array of type student. Then we are adding to it three different students. Then we are sorting this array. Finally, we are printing the array after sorting. You can see in the output that the list was updated and sorted according to the age attribute. That's all for today. Stay safe and thank you very much.